Hello, dear learners. My name is Professor Django. Please remember to like this video and subscribe to our YouTube channel. If you're interested in having a one-on-one online session, please feel free to email me at the address ftpris@yahoo.ca. Once more, welcome to our session. Throughout the session, we will guide you through deriving compound angle identities. We will quickly discuss the importance and then we will dive into derivation. So, prepare yourself to expand your trigonometric toolkit. Why is this important? This learning unit is very important because, indeed, compound angle formulas help simplify complex trigonometric expression. Take note that the expanded form of compound angles make calculation much more manageable. So, throughout this video, we're going to achieve two learning objectives. Firstly, at the end of this session, you're encouraged to master the formulas. You have to learn and understand the core compound angle identities. You're also encouraged to learn the steps in deriving this compound angle formula. Remember that in our previous video, we did show you how to derive cosine of alpha minus beta is equals to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So throughout this video, we will have to derive the remaining three, as you can see on the screen, these remaining three compound angle identities. Let's dive into the derivation of the identity, which states that cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So how do we derive this? The first step consists of rewriting this identity or this formula as you can see here. So here you have to rewrite the cosine of alpha plus beta as the cosine of alpha minus beta. Okay, you can isolate this expression with the bracket as you can see. Remember that we did prove that cosine of alpha minus beta is equals to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So, having proven that, we now rewrite the cosine of alpha minus beta as cosine of alpha times cosine of minus beta plus sine of alpha times sine of minus beta. So I hope you do remember the negative angle identity. You still remember this, right? Negative angle identity, which states that sine of minus beta, since beta is less than 90, we can write it as minus times sine of beta. And we have cosine of minus beta is equals to cosine of beta. So we can use this negative angle identity to express cosine of alpha minus beta as cosine of alpha times cosine of beta. So minus sine of alpha times sine of beta. Remember, this becomes minus sine of beta. You multiply, the negative comes here, you're going to have a plus times a negative sign, and the resultant is a negative sign. So our conclusion is that cosine of alpha plus beta is equals to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. End of proof. Okay, now let's move on to deriving the identity, which states that the sine of alpha minus beta is equal to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. So in an attempt to prove this, you're all encouraged again to recall that the co-function, remember the co-function given by sine of the angle A is equals to cosine of 90 minus the angle A. I hope you still remember this. So we can now rewrite our sine of alpha minus beta as cosine of 90 minus bracket alpha minus beta. Okay, 90 degrees here. Don't forget to write your degrees. So how can we simplify this? We're going to have cosine of 90 degrees minus alpha plus beta to obtain cosine of 90 degrees minus alpha plus beta. Now we can use our previously proven compound angle identity to obtain the following. We're going to rewrite, remember, from the previous proof, remember that or recall that cosine of alpha plus beta is equals to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. So what does this give us? This implies that we can rewrite cosine of 90 degrees minus alpha, we have your bracket, plus beta as the following: cosine of 90 degrees minus alpha times cosine of beta minus sine of 90 degrees minus alpha times sine of beta. We can use the co-function identity to obtain sine of alpha times cosine of beta minus cosine of alpha times sine of beta. So our conclusion is that the sine of alpha minus beta is equals to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Now let's move on to our next proof. Remember, in one of our slides, we did mention that sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. How do we prove this? So here we're going to use our previously proven identity. Recall from our previous proof that sine of alpha minus beta is equals to sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Okay, so therefore we can rewrite sine of alpha plus beta as the following: sine of alpha minus beta. Okay, so we have the following: sine of alpha minus beta equals to sine of alpha times cosine of minus beta minus cosine of alpha times sine of minus beta. Once more, we're going to use the negative angle identity to obtain sine of alpha times cosine of beta minus, because this boils down to minus sine of, so we have our minus times minus cosine of alpha times sine of beta. This gives us sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So our conclusion is that sine of alpha plus beta is equals to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. End of proof. So to conclude, what did we study in this video? We did prove that the cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. We equally prove that sine of alpha minus beta is equal to sine of alpha sine of alpha times cosine of beta minus cosine of alpha times cosine of beta. We equally prove that sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Here are a few key takeaways. You remember that you have to commit the compound angle formula to memory. You have to master these identities and you have to practice deriving this formula. So thank you for following this video. Once more, remember to like the video and subscribe to our YouTube channel. Thank you. Bye.